Hello, so today we are going to learn something about Perceptron, right? So, Perceptron. So, what is this? In machine learning, this is the basic and most popular algorithm to define a class, whether mainly a binary class, whether the class is 1 or 0, or in other words, it is true or false, or like yes or no answer. So in any of these three cases, whenever we need to decide whether the class, whether anything belongs to the first class or second class, and there is only two classes, right? So we use perceptron. So what happens in perceptron? Uh, Suppose there is a uh, first of all, the perceptron concept comes from neurons, right? So in neurons, what actually happens? So in neurons, let me draw for you. Suppose this is the cell or body of neuron, right? And there are many dendrites. Okay. So the input, whatever the signal is coming uh, via these dendrites into the cell, and it then transmits the signal through axon. Okay. So the same concept is used here for perceptron. So we say that there are many inputs, okay, going into the this summer, which we already said it is like a cell body, okay, and this it is giving one output. So this is the only concept of perceptron. So let me give you one example, and this example is from MNIST dataset. Okay, so we all know that in MNIST dataset, each of the image is of 28 pixels in both the direction. So the image consists of 28 cross 28 pixels. Okay, which results to 784. Okay, so this number of pixels are there in one single MNIST image, and this MNIST dataset consists of letter from 0 to 9. Okay, so uh, each of the image will be having 28 cross 28 pixels, and in this image there will be one handwritten letter that will be either 0, 1, 2 or 9. Okay, for example, let us consider it is a 7. So, okay, one more thing. This white pixel, uh, we know, see, for every gray value of 8 bits. The value can be from 0 to 255, right? So if it is a 0, then we say it is a black, right? Proper black, complete black. And if it is 255, then we say it is complete white. Okay. And in between 0 and 255, uh, suppose 140, then we say it is a gray value. So this entire image so may consist any of this value, right, from 0 to 255. So let's go deep into the mathematics part. Okay, so what we said, uh, this is the body or cell of the perceptron. There are many inputs coming and one output. Okay, and this output can be 0 or 1, true or false, or yes or no. For example, if we are checking that a image given image is either 0 or not a 0, either 7 or not a 7. Okay, then we will pass all the pixel dense intensity as its input. Okay, and will find whether our output is 0 or 1. If it is 0, we will say that it is a false. So the given image is not a image of 7. And if it is 1, then we will say, yeah, the given image is 7. Okay. So, yeah. So we are giving, suppose pixel 1, pixel 2, pixel 3, up to pixel 784. Intensity value to this perceptron. Okay. So, uh, yeah, definitely there will be something uh, which will get multiplied and then we will sum, but that I will come little later. So let's go to little mathematics. Suppose there is a vector w, then we will say it consists of, okay, some array, okay, of elements like w1, w2 up to wn. So it is a vector of m dimension. Okay, so for our perceptron part, this pixel intensity will be multiplied with, yeah, with this weights w1, pixel 2 will multiply it with w2, pixel 3 with w3. Okay, and similarly pixel 784 will be multiplied by 784. So this w, we say it is a vector of weights. Okay, and this weights plus one more constant weight b that we say is a designated weight. Okay, designated weight. Okay, in other words, it is also known by bias. Okay, this both are known as parameter. What parameters? Parameters of perceptron. Okay, so we represent by capital phi. Okay, both of this vector w and bias together is known by this phi. So since it is a set, so uh, phi I can be uh, phi I is the ith parameter. Okay, so what I said that capital phi is nothing but a set which consists of vector w union with bias. Okay, so what our perceptron is really giving output as 1 or 0. Okay, if suppose b plus summation of xi and wi. Wi is the weight as what I have already mentioned. Okay, and xi are the pixel intensity input. If their sum is more than 0, okay, then we will say the perceptron output will be 1. Otherwise, otherwise perceptron output is 0. And if the perceptron output is 0, that means the given image is not 7. Okay, and this x vector is the input, means the intensity of the pixels of all the 74 pixels. Okay, okay. So now suppose there are many inputs, right? Vector x1, vector x2, vector x3, okay, up to vector xk. Okay, so now you can understand why I am saying it is a vector, because this is exactly 784 pixels. Okay, so there will be x1, x2 up to x 784, and each of this x is actually a value from 0 to 255, right? And if we normalize this, or in other words, if we divide each of the pixel by 255, then the number will be from 0 to 1, right? So yeah, so if this input is fed to our perceptron, right, then we will get one output uh, for each of this input, and this output for binary perceptron will be either 0 or 1. And suppose if it is not a binary perceptron, for example, if there is only one class, okay, then it will say either this uh, input belongs to that class or not belongs to that class. Okay, belongs to that class or not belongs to that class. But if there are m classes, fine, then the output ak will be from 0 to m minus 1. Okay, so let's speak something about data set. Okay, data set, uh, which we also call by corpora. Okay, so there are actually three type of data sets. One is training set. Okay, training set. For example, for MNIST we have 60,000 training set. What we do with this data set? We actually adjust the parameters of the model. We adjust parameters of the model. By parameter, what I mean? The capital 5. Okay, which is what? Uh, Union of uh, weight, vector weight, and B bias. Okay, so next thing what I want to say is the validation set, that is also known by development set. Okay, so what we do by this set, we actually test the model and try to improve the model. Okay, so and finally our third set is test set. Test set. In this test set, we only test the model. So what I was saying that here the parameter does not changes, and we only test the model. Okay. So for MNIST, this validation set is around 10,000. Okay, 10,000 what? 10,000 images. Okay, and each of these images have one level. Okay, for MNIST, this level can be 0 to 9, right? So we also say that it is true value. Okay, so this all was about dataset. Yeah, the confusion, confusion which most of us do in our initial time is that we get confused what are the real parameters and what are not the real parameters, right? For example, suppose we are training the model, okay, and since we cannot train the model for infinite amount of time, the reason is the model may not converge, right? So what we do, we train for a fixed number of iterations. Suppose n number of iterations, okay, and then we cut our training, okay. So here the cap n, that is number of iterations, okay, is not a parameter, not a parameter, okay. So don't confuse. It is not a parameter, right? Okay. So what I was saying that if I am giving the input k x to the model, we are generating output as ak. Okay. So so how we will train? So we will set b or bias value to 0 and the weights also to be 0. Okay. And then we will perform two steps for n number of times, n times. What are those two steps? First, we will find this value. Okay. And if it is 0, then we will continue. Okay. But if it is not 0, then we will update the weights. Okay. How? We will update it by using this formula. Uh, Change of the weight will be, okay, times xi. Okay. So what is this? This is the change of the weight, that is the new weight value will be existing weight value plus the change whatever happened uh, for in that iteration. Okay. What is this I? Small I. These are uh, these are the respective weights of the pixel. For example, if there are 4 pixels, then this I will be here 1, here 2, here 3, here 4. Okay. And what is this? AK. Uh, these are the true values. True value. Okay. So suppose the perceptron output is 0. That is, it does not belong to class. But the true value is 1. That is, it belongs to the class. Then this sum will be 1 minus 0. That is 1. Right? Multiplied by the pixel intensity xi, and this will happen for of the weight. Okay, for all weights, for all I. Okay, so let me give you all one example, and then I will conclude. So suppose There are 4 pixels. Uh, Let us take its value. See, the weights are already 0, right? For the step 1, for the first step, weights are 0 and B value is also 0. B means bias, weights means the weight vector, right? Uh, then suppose our input x, okay, this is 1, this is what? 0 0.8, 0 0.9, 0.6 and 0. Okay, suppose the 4 pixel value is 0 0.8, 0 0.9, 0 0.6 and 0. We feed this input, okay, and our perceptron gives the output as 0, okay, but in reality the value, the true value was 1, okay. So we need to update the weights. How it will be updated? The first weight, the weight 1 will be W1 previous, this is new, okay, this is previous, plus delta W, okay, delta W1. And what will be delta W1? It will be uh, A1 minus f of x1, right? Whole multiplied by x1. Okay. So what is the our value of x1? It is 0.8, right? 0.8. A1, A1 is 1, right? 1 minus if x is 0, so the output becomes 0.8. So our weight W1 change of weight is 0.8. So our new will be 0 plus 0.8. That means our weight will increase. Okay. So from 0 it becomes 0.8. Okay. Similarly, we can do for weight 2 new. Okay. Weight 3 and weight 4. Weight 3 and weight 4. Okay. So uh, you try it in your homework. So we will do this thing for all the inputs, for all the x, k, right? For all k, for all k. And once we complete the k, we call it as a epoch. Okay, okay. And in that way, our parameters gets updated. Okay. For bias, what we do? We assume what? We assume that its value, its weight, okay, is variable, will be changing, and its intensity is 1. This is just an assumption. Okay. So what exactly happens in multi-class? Suppose in MNIST there are how many? 1, 2, 3, 4, 5, 6, 7. Okay, let's take 4 only. Okay, suppose there are 4 perceptron. So the output will be also 4. Okay, so suppose this is our input. We feed to our perceptron. This perceptron is four, uh, consisting of four perceptron, and it is giving output four output, right? Suppose the output of this perceptron is five, not five. Suppose this is two. Okay, so this is one, this is two. Okay, but the real value is three. Okay, so the true value or the real value is three. So what will happen? This will remain this the parameter of this perceptron will be fixed, will be the same as previous. This will be the same as previous, but number two and number three perceptrons weight will change because it is saying that the output is 2 but exactly the output is 3, and it is saying that output I am false but exactly it should be true. This is telling false but exactly also false. This is telling true but exactly false. This is false but exactly true. This is false but exactly also true. False. This is false but false. So only these two will change. Okay, thank you. Meet you in the next video.